Good morning. So this is going to be a OOPS basic class. Can you see my shared screen? Yes. Okay. Yeah. Okay. So fine. We can get started. So I think 16, 17 was the last class number. So I think we can get started. Okay. So let's talk about OOPS. What is OOPS as such? I would first want to know like how many of you have used OOPS in the past or do have a basic understanding about it. Feel free to write in the chat itself. Okay, you can just use a thumbs up if you want to. I could see 1, I could see 2, 3, 4, 5. Okay. So if I look at it and going by the numbers, it's like close to 50%, I would say. Okay. So let's do an exercise. Let's actually look at the code. Just increase the font size. Okay, so we'll just look at this code for the time being. So suppose I think the font should be good enough now. Yeah. Okay. So if you look at this code, right, what we're trying to do, we're trying to input some student name and age from console, right? So let's do one thing. Let me just do this. Let me just add this code to particular. Let me use ID for doing this rather than doing it static. Let's go ahead and create a new Java class. Let's call it procedural student. Okay, I have made a spelling mistake, but it's fine. Let's go with this. I think I have to make the changes. Let's rename the file. Okay, so you can look at this code. What is this code about? So what we're trying to do here is we're trying to read from console. We're trying to add a student's name and student's age, basically, and we're just printing it out, right? So this is a very simple program. So suppose somebody comes to you and asks, like, okay, I want to basically input student's name and age. How would you do that? Probably this is one of the ways in which you'll do that, right? I'll just run it just to. What happened? Okay, it's already running. So I would just say the student name is Ajit, age is 30, and I get this output, right? So if you look at this code, what we're trying to do is we're trying to input two separate variables, I would say, or values, I would say, when I use name and I use age. Don't worry about the other input stream IO and scanner code. You can basically think of this as basically this is to read an input stream, and scanner is basically telling you from, I mean, you can scan out any values from the console and basically read it from the input stream and things like that. So don't worry about what it actually does. It's basically, you can just abstract it out and think about this as, okay, these two lines of code basically enables me to read from console, whatever I input, right? And then what I'm doing is basically adding a few print statements just to have a prompt on the screen, and adding like basically storing the string in a string called name, and storing the integer age in an int called like in an integer variable called as age, and I'm just printing those values up, right? So far so good, right? So this is one of the examples of procedural programming. So suppose now what happens is somebody comes back and says, I would want to add more than one student, right? Then how would you change this? What you're going to do is basically you're going to ask them, okay, let's do something like I want to ask them first, how many students do you want to enter, right? So you would basically say number of students. I'm going to prompt this on the screen so that somebody is able to basically look at it and understand what to do. I can just copy paste this because I'm going to ask for a number. So it's going to be integer. I can just input, it's like, and I could just say count for the time being. Okay. I have a count, and what I do is for these many counts, I need to run this loop, right? So I'll just run a for loop for int I equal to 0, I less than the count, and I plus this. And I'm going to wrap this whole thing. I'm just going to move this to this particular thing. Okay. Now what happens is, because I want to probably store these values into some variable, I would have to define two variables to store these values, because there's going to be multiple values, not just one value. So what I can do is I can just have like a int array. I'll call it as ages equal to new int of count. So what I'm doing here is basically declaring two arrays with a particular size. Nothing special going on here. String array names is equal to, new string array of size count. Okay, I've done this. What I can do this is, instead of doing all of this, I can just do names of I is equal to sc.nextInt, and I can do ages of I is equal to x. And instead of printing it out here for each student, what I can do is I can again run a for loop, similar for loop. So I'll again run a for loop. Okay, I can copy paste and now waste some time doing all of these. Let me just copy paste here. I could do something like this. Sorry, I would do is sys out name. Sorry, I would want to format it better, so I'll just basically use name of I, and I would just say age. Use the same formatting thing. Ages of, and just to basically have some better formatting in this server. Just call this as okay. It seems to be fine. I'll just try to run this out and see if it works fine. And this. Okay, my lab is really slow today. I don't know why. Probably because of running multiple things. Okay, so I'll just say 2 students for time being. Name, I'll again go back to it. 30. I would say a student name is Abhishek. Age is like 23. Okay, you can see that I was able to display the student details, and right. So now this is fine till now, right? Suppose if somebody comes back and says that, okay, we need to add few more parameters, or we need to take few more attributes for students. So suppose somebody says that I want to take roll number. And then suppose somebody says, I would want to get class information, like the grade information. I want to say grade, admission numbers, and a few more. Suppose I want to continue on doing this, right? There are more of these properties which somebody needs to add. Now you can see this, right? How would I handle this? I will handle this by adding more variables here, right? More array variables to store roll numbers, grades, and slowly it becomes a bit messy, right? So probably you would have 10 of these variables or 20 of these variables. Now it's started to blot a bit. Now what you see is it's increasing to a level where it's difficult to keep a track, right? It becomes a bit difficult to do this, right? Now, coming to this, what is this type of programming called as, right? Because we're not creating any so-called structure to it. It's basically running into like functions, and functions are going to handle. So there are variables and functions only. So we're basically manipulating the data directly using functions as such. We're not providing any structure or anything to it, right? So this is sometimes called as procedural programming, which is, we use it in day-to-day life. So even in OOPS, you'll find some aspects of procedural programming as such, or when you write functions and things like that. But in a plain procedural programming, you basically have functions. You don't have any structure like struct or classes, depending on the type of language you're using, right? So this is an example of how do you write procedural programming procedural program, I would say. Okay, now if I want to do this, right, if I have multiple of this, how can I convert it to make it better? I'll do one thing. I'll basically copy paste this code and make some slight changes to it so that I'm able to do this. So what I'm going to do is create a new class, and this time I'll call it student. Let me call it student. Just call it student. Okay. What I can do is, for time being, I'll just copy paste the code which I have from the previous one, so it becomes easy. Instead of doing student, I'll just call it. I think I should name it better, so I would say student demo. Refactor, convert it to name, so I'll say student. And I will just rename this to match the outside. Now the error is gone. Okay. Now what I can do is, instead of creating these kinds of stuff, right, like where I store individual variables for individual properties, I can do is I could use a structure. What this basically means that instead of having all of these things, like let me write those things. Name and age, I could just do is I can define this into one particular entity as such. How can I do this? I can do this by using something called as class in Java. You'll find this in Golang, people call it as struct, but this basically means that you're wrapping the entity into one, right? So let me go ahead and do this. I'm gonna create a class student. I'm gonna add some parameters to it. So I'm going to keep the things which I had before. So just using 2, because it's going to be tedious to write more and doesn't add much value. So I'll just go. I'm defining a constructor. I'll talk about it, what it basically means. And I'll do is I'll add some getter, which is basically to get these values, to read these values. Okay. So now I have a student class defined. Now, instead of creating all these variables, what I can do is I can just create like an array of students here, right? So I will do is I'll say student array. I'll call it as students is equal to new student array, and the size is count. And now I can change this as, instead of doing this, I can just go back to my value where I say string name and print age, and just define a student, a new student. So I would say student is equal to, so you use the new keyword to basically define create a new object from a class as such. We'll talk about what is object, what is a basic definition of a class, but for the time being, you just understand that we're trying to create a new variable for the student class or new object for the student class, and you're basically using this. So I'll use name and age. Okay, I am getting an error because I think this is probably the wrong. Age should be first and name should be next. Now, instead of doing this, I can just do students of I dot get name and students of I dot get age. I missed one thing, which is basically I need to add the student to the student array, which I have defined student array. Student of I is equal to student. Okay, I'll again run this. Still compiling. Number of students, I'll still keep it to 2. Just do it name, I'll go back to yeah. You can see this, I can do the same thing as such, right? But if you look at my program now, right, it becomes much more cleaner. Even if I want to have like 10 different properties, instead of creating 10 individual variables or 10 different arrays here, I can do is I can just use one class to represent this, right? So what have I done? Basically, I have converted basically I have structured a lot of these properties into one entity, and this entity is defined in a class basically. So now we can, so first of all, were you guys able to follow this example completely? I understand that there are a few nuances of Java involved here, which I would try to explain it a bit, but were you able to understand this program as such? For people who are not from Java background, I would say probably I would more be interested in their response. If you have any doubt about how a few things is done, we can probably talk about it right now. Okay, is there something on the chat? Yeah, I don't see anything in the chat. I think so everybody should be fine to follow this, right? I know this is a very simple example, but this is important because you need to understand how is a procedural programming or functional programming a bit different than class-based programming or OOPS programming as such, object-oriented programming. Yeah. Okay, so we can see here that we can do is we can wrap a lot of these attributes into something called as a class. And we are able to fetch a few, look into these entities using something called as functions or methods. So if you look at this, I can probably use this example to explain what a class is, right? These I can call it as attributes or properties. And this I can call it as methods, which basically defines behaviors. So okay, now I'm gonna go back to the basically the slide. Yeah. Okay. So what is class? Now we have looked at an example of a class, and we'll just try to read the formal definition of a class. A class is basically a blueprint for creating objects, which provide initial values and states and implementation of behavior using functions or methods. A class is a way of organizing information about a type that a programmer can reuse in multiple instances of that data type, right? So now if you look at it, we'll go back to the example. If you look at this example, right? Now at any place where I want to store proper attributes of a student, I could just use this class to refer to all those attributes, right? Instead of storing all those variable arrays or all those variables which we had right previously, instead of passing it around all of those functions, right? For example, let's look into, so if there's a method, for example, let's just try to abstract this out a bit and see. Suppose there's a method where you say fetch student background information, something like this, right? A fetch student information. Suppose this is a method called as fetch student information. Probably I'll define it a bit in Java standards. If I had to do this, if we were defining in the procedural world, we would have to pass in things like, I will if I pass in like int age, int roll number, and a few more properties, right? String name and things like that. Now, instead of doing all of those things, we can just do this. We can replace this with saying that student S, right? It becomes much easier when you try to do, when you abstract out a class, and you can use the reference of this class to refer to a particular object, and that object contains all the attributes like marshaled into one or like wrapped into one as such, right? So what is a class? This is what a class is. A class is basically a blueprint. So I can create multiple students using this, right? And we have done this. If you look at this example, this is the place where we're creating different students. So in the first iteration of the program, we created a student name as Ajit. In the second iteration, we created a student name as Abhishek. And we're going to store this in an array and we can do it, right? So student becomes a blueprint for us. In real life, you can look around any of your stuff and you can create a class out of it. If I look at a house, I can just look at a house and I can look at the properties of it, right? What would a house have? A house would have windows, a house would have doors and things like that, right? So I can create a class called as house. And then I can say that it has an array of windows, an array of doors and things like that, right? So what does class help us? Class helps to model a real world entity into a programmable entity as such. It helps us to make those connections, right? Okay. So going back to the presentation. So anybody has a doubt about what a class is? Okay. Next is about an object. What is basically an object? An object is an instance of a class. You can just look at it and say, so in the previous example, when I say a house, we have defined a house as having things like doors, windows, and things. So we have defined a house class which has multiple doors, multiple windows, and like a lot of those entities, right? Now, if I want to create like a real world instance of that house, which I could just say is my house. So I live in Bangalore and I live in a flat. I can just say that Ajit house. If I create an instance of a class called as Ajit house, where I define it like is equal to new house, and I say I have 5 windows, 3 doors, and things like that, right? So this particular house or Ajit house becomes an object, which is a runtime entity which is created out of a class. So class is a blueprint, and the moment you pass in values to that class and create an instance out of it, right, becomes an object. And against this object, you can do operations, whatever the class permits, right? If your class says that you can get the number of doors, you can do number of doors. If there's a function defined as enter house or something like that, right, you can perform those operations. So we can just say there's another class called as a person, and a person can enter a house, something like that, right? So we can define behaviors on it. Don't go too deep into how those objects or different objects would come together and like interact with each other. We'll probably discuss this in the future classes as such. But yeah, so object is a basic instance of a class. It's basically like a runtime entity as such. Okay, any doubts here? Okay, so moving on. Now, this is a bit which is basically I was a bit conflicted. Should I talk about this? Should I not talk about this? But I think because we are gonna like discuss examples on Java, I would basically want to do a few things. Is I would want to discuss about what is basics of Java, so that anybody who's not even from the Java background is able to understand this. Please don't. I'm not planning to go very deep into Java. I'm just gonna use the basic minimum required for understanding those Java programs as such, because you can do OOPS programming in any of the modern languages, be it Python, be it C++, Java, Golang. You can do it in any of the languages right now. Right? Most of the languages support it. So we're not gonna go very deep into one language per se, but just because I would want to use some examples and show you some learning examples, probably I've gone ahead and used Java for those. So discussing a basic for it. Now, okay, what is a package in Java? So if you look into this, I've defined something called as io.github.akcps.class basics. So this is basically like a package. You can think of package in Java as a collection of classes. You can see that inside this package, we have 3 classes, which is class, procedural, student, and student demo as such, right? So you can define, you can basically define multiple classes in a package. So a package is basically for storing or for having similar kinds of classes, right? So suppose if I'm gonna work on student, or let's talk about some real world example. Suppose I'm working on building something like a Swiggy thing, right? So I could define a package called as restaurants, and all the classes related to restaurant go inside that package. I mean, there are multiple ways in which people can carve out packages. I'm just using an example, right? So there are an example of somebody trying to do an online food delivery system. There would be multiple entities, which I mean, I can just top of my head, I can think about. They're going to be restaurants. They're going to be delivery people, right? And yeah, these are the 2 basic entities I would say about the actors in this space. But you can think about these 2, right? So anything which I want to do against a delivery person or against a restaurant, I can define 2 different packages for it, and all the class related to it can go into that package. So package is basically a collection of classes, and you basically keep it in that form because you want to basically want to abstract out a few things around that layer itself, or you want to define certain behaviors, or you want to carve out something. Like in the future, if you want to use, okay, let's not go there. You can just think of this as 2 different, you are creating 2 different folders for it. So suppose if I look at my laptop, I have defined it like, we do have like different folders, right? Why do we do that? Because we want to specify that, okay, this contains my software engineering notes, this contains my finance notes, and things like that. So I'm basically trying to separate out 2 different units or particular types as such, right? So you can use packages in doing that. So that's what a package is. Okay. So package, subclass, and this is world. Okay. So now, as we know what a package is, if you look at this particular keyword here, what I have defined in front of a class, is this, these are called as access modifiers in Java. What does access modifier actually do is basically gives you permission of visibility. So who can actually use this, or who can actually see these entities as such? That's what access modifier does. Okay. So in Java, we have 4 types of access modifiers. One is public, which is kind of like, I can define a class using public. I can also define a variable using this public. So I can use public. This. Okay. So one is public, and you can see that the constructors are always public. So in this case, the constructor would always be public because you would need to look at the constructor, or you need to access the constructor to create any object, right? So they would always be public as such. If you have a private constructor, you can have private constructors, but yeah, it does not make sense for anybody who's using it from the outside world because they would not be able to see that private constructor as such, right? Or probably you can, sorry, I'll take my words back. I don't think you can ever have a private constructor. So these are the 4 keywords, which is public, which basically means that it is visible to all. And this is what it is, right? So let's go one by one. Public, is it accessible in the class or visible in the class? You would say yes. Accessible in the packages or outside of the package? You would say yes. Let's refer to this package as the package under which the class is defined. So I would say that public variables or public entities are accessible within the package as such. Subclass, we'll come to this, which basically means that when you inherit a class from a parent class, are you able to see the properties of this particular, like whatever properties are defined in public? We'll probably go in depth about this, like the subclass or the child class. But for the time being, just think of this as a class created out of a parent class, and that's it. So you would also be able to see it in the public, like in a subclass, the public thing. And is it visible to anything outside of this particular package or things like that, which is the world, which is yes. So a public access modifier, be it a class or be it a variable, is visible to anybody from anywhere, right? So that's what world means here. Protected, so it's also like a keyword which we use in Java. You can define like variables and like using protected. And when you define variables using protected or attributes, it basically means that it is only visible inside the class. So the class inside this can use it inside a package, inside a subclass, and for the world, it's not available as such. So anybody from outside the package will not be able to access it. Default modifiers. So if I go back to the example, in this case, I have not defined any of the access modifiers, which basically means that I'm trying to use the default modifiers as such. The visibility for default modifiers is in a class, it is visible. In a package, it's also going to be visible. In a subclass, it's not going to be visible. And in a world, it's not going to be visible as such. Private modifiers, it's basically says that in a class, you would only be able to access it within the class. Outside of the package, subclass, and things like that, you would not be able to access it. Okay, yeah. So this is about the access modifiers. We need to know this because in a few of the programs, you would find something as public or protected or things like that. Don't worry about it. This just means visibility from where you can access it. Okay. Now coming to the principles of OOPS. Let me do one more thing. Okay, so let me take a break here. Let me just take a pause and ask you guys, like, do you guys have any doubts, anything which you want to understand or anything which is not clear?
Ajit, I have a question on previous slide.
Yeah.
This is regarding default.
Yeah.
So,
yeah.
Okay, if we do not have any modifier, then within the class, that particular data member or variable is accessible inside the member methods, right?
Yeah. Yeah.
And what about package? Package, that means if I have another class in the same package, so does this mean I can access those variables of that particular class in another class that is present in the package?
Yeah, I think so. You would be. You should be able to access it. Let's try out an example and just check it out, right? So I have this public class car. I will define another class, I would say T car. Okay, inside this, if I say I want to, okay, so what we're trying to do is inside a car, we want to see whether we are, okay, let's have a, say, I have an example. This is a different example. I think I've not discussed this example with you, but I will just try to do this. Mm, yeah. So let's try to run this. Yeah. Can you see this? I was directly able to use this color
In
on
yeah, in another class in the same
another
package.
class itself, right? So
So Ajit, if I have subclass in the same package, then it
yes,
will.
yes, yes.
Mhm.
I get your point. So if you have a subclass in the same package, then you would be able to access it.
Okay. Okay.
But so I mean, inheritance, uh, like you can do inheritance outside of the package also, right? So when you're trying to inherit a class in from a package A to a package B, right? If my child class is defined in package B, now then there you would not be able to directly use this variable as such if you define it as default. If you define it as protected, you will be able to do that.
Okay. Got it, Ajit. Thanks.
Okay. Yeah, Prajmal.
Ajit, I think he asked for the default class. Like, is it a keyword we are going to use instead of public, or is it we are not mentioning anything there?
Yeah, so are you talking about something like this? So in this case, I'm not referred to this class as a public class. Is this what you're talking about?
Yeah. So, is this we can use in another package class? That's what I think he was asking, and that's also my question is.
Sorry, so you want to say that can I use this in a different class altogether?
Yeah, and different package.
Yeah. So in a different package, I would say no.
No. Same package. Sorry, same package, different class as we are using now.
Okay, let's try it out and see. So I have
Yeah,
this, right? I would just do this. I can do this, right?
yeah.
So it's visible to me, right? So this is what it means. In the
Yes.
same package, you're able to do that, but outside of the package, you'll not be able to do that. So let's try to do this. I don't know these packages. I don't think so. Inside these packages, you would have these class. I will just create a new class. Mm, I'm just I'm bad at naming stuff, so I'm just naming random stuff. Uh, void main. I'll just create a main class. If I try to do student, you can see this. I'm not getting a prompt for student, right? In this,
Yes.
I'm getting for a procedural student because it's a public class, but I'm not getting get student class because it was designed as a default here.
Yeah. Okay.
Okay, got it. Yeah.
Yes.
Okay. Okay. So access modifiers, is it clear to you guys? Okay. Yeah. Now I would move on from it. Next is about principle of hoops, but I think we would also go back to some more Java basics, and I'll just remove this class because it's giving me an error. This. Okay. So now let's try to do is so in Java, probably for hoops, we also need to understand a few more concepts, which is what I think we understood what class is. Next, we'll talk about what is an abstract class, and then an interface, right? So let me try to define an abstract class. Okay, let us name it as not using student anymore because student is getting confusing. I'll let me name it as person. Okay. I'll just do is I'll use a keyword abstract. Okay. So first of all, abstract keyword can be used at two places, I would say, when you're trying to define it as a class, or define a class, or when you're trying to define a method as such. So right now, what I'm doing is I'm defining an abstract class called person. So in abstract class, you can have some attributes. So I could have, again, I'll use the same thing. I could have int age, and int, it will start giving you errors. I will talk about why it would be giving me errors. Student, I would say string. Okay. I can have like a constructor to it. And now I can define things like, I could define an abstract function. What does an abstract function means? Let me define this and probably then we'll talk about it. Public void, I would say just say display. This is a, what did I miss? Okay, if I'll have to use the abstract keywords. Okay. Now, if you can look at this in abstract class, what I'm doing is I'm defining a method called as display, which is abstract itself. What does this actually mean? So, an abstract class basically means that it is not a real class, I would say. So, real class in a sense, it does not have all the implementation what is needed to basically. It might not have all the implementation which is needed to run or like create a real world entity out of this. What it has a structure, and then it has some contracts. In this case, display is a contract saying that all the child classes who wants to inherit the properties of this person class would have to basically override or implement this method called as display. Okay. Now let's do another example in which I'm gonna create another implementer class, which is call it as person demo. What I'm trying to do is I'm trying to see if I can create an instance of this class, right? So I've defined it as person. I could say person is equal to new person. Can you see that I mean, this ID gave me a thing, right? Like, let's not go there, but like, can you see this, right? It's giving me an error. Why is it says, right? It says person is abstract, cannot be instantiated, which basically means that this person class, it's not completely complete, right? I have one contract defined, which is display, right? So if I try to create an object out of this, as it is not complete, I would not be able to create an object out of this, right? I will always get an error. So there's a way in which you can define it on the runtime. I would probably not discuss this today, but understand this, that this is what happens when you try to create an instance of the abstract class itself. You'll get an error because abstract class are supposed to be a contract or a structural contract, and you need to basically have an implementation class for it for you to create an object. You can use the reference. The reference is basically the left-hand side thing, right? So when I say person, this is basically a reference that I'm trying to do. This is trying to create, but yeah, this is I cannot do a new person class without implementing the display method itself. This when I try to do this, it basically says now you'll have to override this method because yeah, the abstract class is itself not complete without this implementation. Okay, so I'll just revert this. Okay, now this is an abstract class. How do I extend from how do I basically extend from an abstract class? I could do is I could go and create a new Java class. I would say what would be a good inheritance of person? I would say I am using person. Chalo, let's create a teacher class or a driver class. Probably let's create a driver class. So there's a class called as driver. What I can do is I could basically, using that abstract class structure, I could define a new driver class. So I would use the extends keyword here, and I would say person. Right. So now what I'm trying to do is I'm trying to create a child class, or basically use the structure of a person class to you reuse the properties or reuse the attributes which are already defined and to extend it if I need it, right? So the moment I do this, right, when I say extends person, I'm like my ID prompts me that it's an error. Now, if I look at this, what is an error? Class driver must either be an abstract or implementation of method display in person, right? So I need to do is I need to implement this method. If I just do this, it says, okay, this is fine. I can just do this out. I would just say driver here. Yeah. But you can see this, I'm still having an error. I was able to override the display functions, but I'm still getting an error because it's a concrete class and it would ask you that you should have a constructor for it, right? There should be somebody who's able to access it and create it, right? So either you can have a default constructor or you can create a constructor matching the superclass. In this case, the superclass is the person, right? So it just basically says, I have created a constructor for driver class, which takes an int and age and basically calls in the superclass constructor for it and passes the age and name to it, and it basically overrides the display method of it, and we can basically create an object for this. Now what I'm trying to do is I'll go back to my person demo and I'll see whether I'm able to use this or not, right? So instead of creating a person, let's do this. I would just say driver. I will be able to use a driver reference, right? So I'll be able to create a driver object saying driver is equal to new driver. And I can pass the age as 25 and right. Okay, I missed this. I need to create a public static void main class. Okay, I'll just try to run this. That's the thing I need to call. Okay, I just called in. I forgot to call this, right? So now if I call this, right, what happens is I've created a driver class object, I assigned some values to it, and I'm just calling the driver method basically for it, and I could just get it, right? Driver display driver here, right? So this is calling this. Can I use the parent class here? If instead of referring it as driver, I could just use the parent reference. Instead of that, I could just say person driver, right? Because it's the parent class. I would be able to use the parent class like definition or the signature to create a driver, basically. Why is that? So, okay, first of all, let's run this. Wow, it's really slow. Yeah, you can see this, right? I still get the same response as such, right? Now, there's an important concept here, right? Why am I able to assign person driver, this driver reference to a person class, and still I'm on the right hand side, I'm using driver. Why am I able to do this, right? This is because if I again go back to the person class, this is because I've defined a person as an abstract class, and I'm inheriting, the driver is basically inheriting from the person class. What does it mean? It means that a driver is a person. So here we talk about a relationship called as is a relationship, which basically means that any child class is a relationship with the parent class. So is driver a person? Yes. So, and it has a certain kind of relationship, which is it is a relationship, which basically means that it is also a type of the parent class. So driver is a type of driver, but it's also a type of person. So that's how you basically understand this. Right? Okay, now I could create multiple objects out of this person class. Sorry, multiple implementations of this person class. I could have a driver. Now I could have a, like, I could just create another class called as cook. I will again do extends person. And I would basically have to do the same thing. I would just say constructor, I'll just use the constructor, and I'll still have to override the display. Override methods. I just want to override from the base class, which is this. Let's see this. I'll just get this out. Okay. Now, if I go back to the person demo class, I would still be able to do something like this. Person three, three. If I again run this, yeah, you can see this. I can do that, right? Now, a question to you guys is: can I assign a driver reference to a cook, or can I not? Can I do something like this?
I think not.
Okay. Why is that so? Isn't it from the same parent? It should be, right?
Because cook is not driver. So there is
That-
no relationship between these two.
Yeah, you can see this, right? It starts giving me an error. Why? Because though they inherit from, they come up from the same class as the same base class as such, but they are like two different, I would say, subclasses, and they don't understand each other. They understand the parent thing, but they don't understand this, right? If I look into this and say required type driver provided cook, okay. Now I would just use a whiteboard to.
I think it's one directional relationship. That's why,
Yes, yes.
like,
Yeah, exactly. Okay, I think that's gonna be fine. So do you guys understand what an abstract class is? Anybody has any doubts on this abstract class? So the thing, so basically, how is a class different from an abstract class? An abstract class basically has can have some states. So I can define. So these are the states, right? So I'm carrying these as like attributes or states. These are attributes, states. So an abstract class can have some states, and it can also have some abstract methods, which basically means that anybody who's trying to extend this would have to implement this, right? Now, if I remove this keyword, it's gonna start showing me errors, right? But it's gonna say that, okay, you in a non-abstract class, you cannot define a like abstract method as such. Okay. So in a normal class, you can't do that. Can you extend from a normal class? I think yes, you would be able to extend from a normal class. So if I just change this to a normal class, and if I just change this from abstract, okay, I'll change the signature. Instead of doing it as abstract, I would just have public void display. And now, because I have this, I would have to add some implementation. So I can add some implementation that I'll just say parent or person. I'll just say person. Now, if I go back to person demo and I rerun this, okay, what would happen? Will the output change? Anybody?
Yes, output will change, Ajit. Only parent class method will be called in all the cases.
Are you sure?
That is what happened in C++. That's why I'm guessing. I'm C++ guy, but
Okay,
I think, yeah.
Okay, no worries, no worries. We'll just see how it. Wow, so slow. Did you see what happened? It still remained the same. Any guesses why did it not use the person's display method? Why did it use the driver and cook's display method? Anybody?
We are creating
Yes.
pointer.
We override the method.
Yeah. Sorry. I heard the right answer, but I would prefer you guys to speak one at a time. So probably raise your hand, and probably it becomes easier for us to follow. But yeah, somebody said that the right answer. Okay, Pradyuman, you can go ahead.
We are creating a pointer on a particular class, that's the cook and the driver. Okay. So basically, whenever we are calling the method, that's the display method. So it will check that particular class with the new keyword we are mentioning. And if there is not that method present, then it will check the parent only. In that way, it will work.
Okay, got it. Yeah. So yeah, you're right in some sense. What happened is, in simple terms, and somebody said this, right? What we did was we used something like a overriding property, right? So what I'm doing is, though I have defined a specific implementation in my parent class, I said that now don't use that, use this, right? So this is the thing. Now let's try to do some more.
I have a doubt.
Okay, yeah.
I mean, this bonding happen at the compile time or the run time. See, we are giving reference of an object. I mean, the parent, right?
Yeah,
Reference is parent. Then it will go and check the method whether it is defined in the child or not.
Yes.
Right. So, I mean, at what time it will be happening? That kind of check.
Yeah. So this happens at the runtime.
Okay.
Yeah. So actually, this is a good thing, but I wanted to wait back to talk about all the OOPS principles, and this is one of the principles which is called as polymorphism.
Okay.
Which is if you use a reference of a parent identity, or if you use an abstract reference or some high level or a top level class in reference, and you have something on the right, you can do that assignment, and you can basically on the runtime basically decide which object to create as such, right?
Mm-hmm.
So in compile time, it just says that how would Java work? It's like they will try to compile and see whether is it like matching is a reference. In this case, it did, right? Before this, when we tried to do the other one, we were trying to assign driver reference to a cook object and things like that, it failed. Why did it fail? Because it knows that this does not match the exact types as such.
Mm-hmm.
So that's why reason it failed. The compiler would will just check for the types while compiling this code, but at runtime it will basically go ahead and check, okay, so what should I pick up and things like that. And that is what is a polymorphism basically means. But we'll come to polymorphism in a bit. It's basically the same thing. Sorry.
Yeah, one more thing. Is it different in Java and C++, or this concept will go through all the languages?
Yeah, so right now, I'm sorry, I think somebody talked about C++ implementation where they said that probably the parent class will be called. I'm to be honest, not a C++ expert here, so I'm not really sure. Ideally, it should not, because it should override it. I mean, if there's something special in C++, why it doesn't happen, it's probably something we want to do. But think about this, right? So
Ajit, sorry, I have answer for this.
Yeah.
So can I give?
Yeah, sure.
Yeah. If we do not have abstract class, that means it is not a pure virtual function. But if that is virtual function, then it will behave the same way that is it is behaving in Java.
Okay.
If we do not have virtual keyword, then definitely parent class function will be called.
Okay, got it. So basically, C++ defines it that if you have a real implementation, it will try to pick that real implementation. But only if you have a virtual implementation of it, then it allows you to override it. Is that correct?
Yes, Ajit.
Okay, got it. Yeah. So, I mean, here we have the answer. So most of the time, I mean, I would say, yeah, in this case also, right? Java is giving you to functionality to override like a concrete class. Methods also probably the other languages might be a bit strict and might not allow you to do that. Right? Yeah. Okay.
And yeah, one more thing. Why we really need this abstract class?
Yeah.
And
So think about this, right? If I go back to this person class, okay, if I go revert back the stage, right? If I say at any point of time, suppose you're creating a class hierarchy, and you say that everybody is gonna do this thing differently, right? So there might be a parent class who knows that I can do 4 5 things. I know it's gonna be consistent and constant, but the sixth thing which I want to do, I don't know how other people want to do it, right? I'm not really sure how they want to perform this operation. So what I will do is I would not take the responsibility of defining it out for everybody. I would just create an abstract saying that, okay, everybody who's trying to extend me would have to do this operation, but they can define what happens in that operation. That will make sense. So in this case, you can just look at this and say this, right? In this case, the reason for me to call have the display function as or method as abstract was basically to say that I want to display what type of class it is it, right? I can do it in other ways also, but I would say one way to do this was I want them to tell me what they want to display in this method itself. They can display anything which they want to. I don't define what they want to display, right? So there are cases, and in real world, you would always have this, right? So that the parent is able to define a few like state and a few behaviors on their own, but a few more behaviors which they want the child classes to have, but they would not be able to define it concretely. In that class, in that case, you would want the child class to actually do it, and that's the reason you use abstract classes with abstract methods. It's basically saying that I can do these things for you, but these two things you have to do it. But this is a contract when you try to do this, and things like that, right? Mukul, is it clear?
yeah. And one more thing, suppose I in the child class, if I don't want to implement this abstract method, can I do this?
Let's go back and check. I don't think so you'll be able to, because the moment, okay, let me go back to say, is there abstract? I'll comment out this implementation. I wanted to show you another example. Probably we'll come back to this after this doubt. Okay. If I go back, okay. So now in this, if I just do this, right, I'll just, you see this, it starts giving me error. It says you cannot do it, right? You will have to do it. You'll have to implement this method. It says class driver must either be declared abstract or implement an abstract method called as display. Yeah.
Yeah. Okay. Thank you.
Okay. Yeah. Okay.
Sorry, Ajit, one more thing. Can we remove this override keyword? I mean, let's make the parent class non-abstract class, and let's have display function, simple function in that. And this is our driver child class.
Okay.
Yes.
Got it.
Yeah.
Got it.
So I think now parents display should be printed. Let's have this, but without abstract keyword. Let's have this display.
Yeah. So I'll have
in
this.
Parent.
Yeah, I'll have this implementation here so that it becomes easier. And this is right? This is what you want to say. And if I go back,
Right. I think now parent should be printed. I think. Still that. Okay. So this is the difference between C++ and Java.
Yeah.
Here C++ program will print a person,
Yeah.
but this Java program still prints a child class.
Yes. So you can think about this as whatever I've used in the right-hand side, it will try to, so, okay, one cheat code or one way to understand this would be on the right-hand side, whatever I decide as a new keyword, what it tries to do is it tries to find whether in that particular class, do I have this particular method? If not, then it will go to parent. So my relationship is between like parent, child, and things like that, like from top to bottom. But when you're looking for methods, probably you look this way, right? So if I've defined a object of this class, probably I look into whether this class has this, neither then I'll go to the top level and things like that, right? Okay, is it clear? Okay, I'll do is I'll go back to this example and I'll do something interesting now. I'll define this as abstract, and I'll go back to this abstract, define this as abstract. Now I'll do is I'll create another method which is not abstract. Public void. Now what happens is this. Why is it giving me an error? Okay, let me complete this. Public void. I'll just call it as print. Print. Okay. Now if I go back, for the sake of simplicity, I'll just use the overriding keyword again, because it's just a good norm to do it. Okay, now I'll go to the person demo class. If I call now these two classes, the driver and the cook class, does not have that particular method as such, right? There's no print class, print method in those classes as such. Now, if I try to use, can I use that method first of all? Would I be able to use that?
Yes, Ajit, I think we can.
Yeah, we can, right? And we can do this, right? Now we'll just try to run this. Why is my laptop so slow today? Okay, you can see this. It goes into driver here, parent person, right? So I'm able to call those methods as such. Now, if it's not defined as abstract and I want to override it, I'll just try to show you the example that we can override it still. Should I? Just need to check whether we can use the override keyword. I think we can use the override keyword. I would say driver. I'll again run this example. Okay, driver print.
I called it driver.
Yeah, I just made a mistake. I used the wrong reference, I think. You can see this, I was able to override this, right? So I was able to override the behavior of the print method, which was defined in the parent person class. Okay, now let's go back and let's try to see what do we learn from all of this. Why would somebody use this, right? So if I look at this, right, I could have a implementation in an abstract class or in the parent class. And what happens is, if I don't override this or if I don't change the behavior, it's going to remain the same, right? So think about a scenario in a real world where probably when you're defining the parent class at that point of time, you know that, okay, this is how it's going to work. So instead of writing the same piece of code in all the child classes, you can just leave it in the parent class itself. Or think about a scenario where you did not do inheritance at all. So you had like a person class, you had a driver class, you had a cook class. Now the same code you've written in all of these three classes, right? Because there's no relationship as such. So what you're doing, you are basically writing the redundant code there and you're doing the same operations at every place, right? So now instead of doing that, if you use inheritance and we're able to create a structure or a hierarchy and then use it, we are saving it, we are saving ourselves from bugs by writing that same code at only one place and changing it whenever required, right? So once if I change the implementation of print here, it gets changed into all the child implementations, right? So it's a good thing, and as well as it's a bad thing. I would not say it's always a good thing, but yeah, I mean, think about this. In some cases, it does make a lot of sense, right, to do this. So now you understand why people would like want to do inheritance and things like that, right? So that you don't have to do the same implementation at multiple places, and you are able to do it, like write the code at once and reuse the same behavior in all the child classes. Make sense?
Yes, Ajit.
Okay. Now moving to something. So we have looked into what is classes, what is abstract class, and now one more piece of the jigsaw, which is called as interface. Okay. So let's call this as person interface. I would want to use the same example so that I don't have to change much, but I can show you how to do it. Right? So I'll call it as an interface. Okay. Now, first of all, in abstract class, we could see that you could have some states. So I was able to define like attributes like name and age there, right? And I could define a few behaviors, right? Like for example, the print method, I could define like exactly how the print method is gonna behave. The difference in an interface is that you cannot store states. You can store constants, which basically means that things which don't change at all. So in if I go back to this person class, these are not constants, because you are reassigning values to it, or you're probably not assigning any value to it right now, but you are assigning to it when you're trying to create an object and things like that, right? So these are not constants. These are attributes which can change, right? But when you do something like when you want to write constant in Java, you can write something like public static final. So I'll say something else. You generally write it with the caps. What would be a person interface code? Life duration. This is a seriously bad way of writing it. I'm not getting right words right now, so I'll just say life duration is 30. So you can define things like that, which basically means that it's a constant. It's not a state as such. A state is one in which you can basically change from value A to value B, which is a variable kind of a thing. But this is not, you cannot reassign a value for this life duration entity as such. You will not be able to do it at any point of time, right? So in an interface, you are able to define constants, or you're able to define the contracts for methods. For example, in the last thing which you saw, right, in the person, we are able to define this as a contract, right? We're saying that everybody who's trying to implement would have to implement this, right? So I can again do this. I could go back to this particular interface and I could do this, right? Now you can see it basically grayed out these things. Why? And you say that it says remove unnecessary public and abstract, which basically means that you don't need to do it. By default, anything which you write inside a interface, it's going to be public. You can just remove this and this is okay, right? So in the person interface, I'm defining a contract. I can only define two particular types of things. I can define static methods, but let's not go there, because probably in most of the cases you would not want to have static methods in object-oriented programming. Static is kind of an anti-pattern, so let's not. I'm not interested in discussing it mostly. If you want to read through it, I would give you references for it. So, but I think for the sake of oops, let's not talk about static stuff. So in an interface, what are the two things which you can define, or one of like few of the two things which you can do is you can define constants and you can define contracts for methods as such. Now, I have defined this as a constant. Again, I'll have another one. I would say person interface void hobbies. I would just say hobbies. Okay, so I have two methods defined here. Now I'll go back to the person demo. Or no, I'll go back to the person class. and sorry, the driver class. And in this case, what I'm going to do is instead of extending it from person, I want to use that interface which I've defined. So in order to basically extend out of an interface, you don't use the extends keyword. Instead, you use the implements keyword as such. So you can say implements, and I can just say person interface. Right. Now I'll have to remove this things because there's no more. You don't need to call super because you do not want to call this. You have to define these as local variables or things. I would just say string name. I would again say this dot age is equal to age. Sorry. This dot name is equal to I can't do this. There's no, instead of this, I would do is I'll change this to hobbies. Okay, let's try it. Let's play around with this to understand this better. Says one problem. Okay, so if I go there, it says some problem is there, right? Class driver must either be an abstract or implement abstract method hobbies in person interface. So in this person interface, I have defined two methods, right? One is hobbies and one is display. I'm overriding one. I'm not overriding two. So it's not, basically it's giving me an error, right? So you should understand this, that if you're trying to implement out of an interface or implement from an interface, you would have to define like all of the methods which are there in the interface. You cannot get away with implementing only a few of those, right? So in this case, I'll just go to override methods. I'm not going to override the object class. I'm just overriding this hobby. And I'll just say this is a driver. So I would say driving is my hobby, driving. Okay. Now it says another one related problem. What is this problem? Yeah, this is a problem, but we'll go back to it later. Now I'm also going to change cook as such, and I would say implements person interface. I'll again have to store now the states. So this is a good example in which you can see that how is an interface different from an abstract class. We're probably going to achieve the similar kind of things, but in abstract class, I was able to define states there itself. I was able to define the string age and name in the abstract person class and basically use it. But if I'm using an interface, I would have to define it in the child classes or the classes which are trying to implement this. I'll still get the same there. So I'd say cooking is my hobby. Okay, this is fine. Now I'll go back to the place where it's creating an error. So now I cannot use this person. Okay. I will just, for the time being, I'll just use driver. This will go away. There's no there's no something called as print now anymore. So I would say hobbies, and this I would say cook. Again to hobbies. Okay. Now I'm going to run this. What do you expect to see? Yeah, so you can see that the driver in the first case, we are able to see driver here and driver, which is basically displaying things which are in the driver class, and then for cooking and cook here, right? Can I use the interface reference here? Okay, first of all, let's try to create an object for the interface. So if I say person interface, I would say person interface is equal to new person interface. Again, the same thing, right? It will not let me create an object until unless I do both of these implementations, right? So you cannot just create a reference. You cannot create an object directly for an interface. You will have to do the implementation, basically, which means you're overriding and creating a new class or something like this, right? You'll have to override those properties in order to create an object as such. You cannot do it, right? Directly. Okay. Now, can I use person interface reference to create a driver or create a hook?
Yes.
Yes, exactly. So this is now if I run this, I'm gonna get the same result out. So nothing special here. Yeah, got it, right? Okay. Now, so now we understand what's a normal class, what's an abstract class, what is an interface, and we are able to like go through a code and understand a bit about it, right? So I'll take a pause here. I think you guys, if you have any doubts, you can go ahead and ask about this. Anything which you don't understand about this. Yeah, Pridhvi.
Can we use extend and increment at the same time, like extending a class and implementing the interface in the same class?
Yes, we can. Let's do this. Okay, now I'll have to do this. I'll try to change minimum from here. So let's do this. Yeah, the print class already has an implementation in the person thing. Yeah. That have it, right? So that's fine. Which one was it? Which one was I looking into answer? Sorry. I think I was changing book. No. Change the driver implementation, right? Seriously. Cook is the one which I've changed. So I'll go back to person demo. Now, will I be able to do this? Do you see something here? So this cook class does extend person and does implements the interface, person interface, right? But I'm not able to basically call the print method from this cook class, like which I have already defined in this person abstract class, right? Do you know why? Can somebody answer?
Two parents actually of the same class, and no relation between the parents.
Yeah, I would say not really two parents, but if you look at this person interface, right? So the reference is of person interface now. But the person interface does not know anything about this print, right? There's no relationship between that, right? But if you look at this, it only understands these two things. Now, if I change it to person cook, the same issue. Why? If I go inside this, I understand this. I mean, the person class understands this and understands this. It does not understand what hobbies is, right? Does that make sense?
Yes.
Okay. Now, if I had to fix this, the easiest way to fix this is do this. Okay. I'll just run and see. Okay, all good? Yeah. So did you guys understand what happened here?
Yes.
Okay. Any more doubts on this?
Ajit, one query that is regarding interface and abstract class. So interface, if we have two methods inside that, so the class that is going to implement it has to define both the methods, right?
Yeah.
Has to override.
Yeah.
If we have two abstract methods in an abstract class, then the child class must also override both the methods, or is it also possible in Java if you override one method that can work?
No, that will not work. And let's see it by an example. So in this case, we have override this display method. Let me try to do is create another abstract method. Public abstract void do. I won't have it. It means if I do this, right? What happened? Okay, let me go back to this. I would go to the driver class now. This is implementing from interface. Okay, sorry. I'll probably have to go back to the hook class. Wait, there's some error here. Why is this error? Move member into the class. Why is this? Sorry. Did I define some? Okay, this is not the right. Okay, do is not the right keyword. It's a keyword, right? Shit. Okay, sorry guys. So when I'm learning, do is a keyword which is like a do while loop. So if you try to name a method using do, you'll get an error. It will not let you do that, right? So now I can see this, right? I've created another abstract method. Now if I go to cook, sorry, in this case it says the starts showing me error, and if I want to know what the error is, sorry, it should tell me what happened. Tell me. Okay, it says class cook might either be declared abstract or implement abstract method done in person, right? So you can't until if you want to create a concrete object for that particular, or if you want to override or create a child or implement or extend. So anything which is abstract or not defined in the parent class, right? If you want to do a concrete implementation, you will have to override everything which needs to happen, right? So in this case also it says this, right? You would need to implement both the methods in the person class to basically be able to extend it. Yeah.
Right, Ajit. So the only difference is the state of the class. In abstract class, we can have state, and in interface, we can't have. We can have only constant values. So that is the only difference, right?
One more difference. If you look at this, you can do an implementation here, right? I could define the behavior
Right.
of the method.
Okay. Yeah, got it. So
Which
two
I can't do
differences are
in
there. Yeah.
right? And this is useful, right? So again, going back to the example which I said, right? If you know that this is a parent class and all the child classes have a behavior, same behavior, you can just write that method in the parent class itself. Okay, I don't want to talk about definitions because I think you guys can find out definitions at any place. I'll just say what this basically means, and I'll probably try to tie it down where we have used this in our examples as such. What is encapsulation? So in the first example, which I showed you, were like what's a procedural programming versus object-oriented programming. I've shown you things like student, instead of having different arrays for ages, like name, age, and things like that, we wrapped it into a class called a student, and we use that, right? So what is encapsulation? Encapsulation basically means that defining a structure, which we do through a class, and wrapping it up like a student is basically an abstraction or an encapsulation of properties like age, name, roll number, and things like that, right? So that was encapsulation is. You encapsulate a few of these attributes into one unit, which in this case is a class. Okay. What's abstraction? And abstraction and encapsulation goes by, I would say, hand in hand. Abstraction is basically an abstraction of properties like age, name, roll number, and things like that, right? So that was encapsulation is. You encapsulate a few of these attributes into one unit, which in this case is a class. Okay. What's abstraction? And abstraction and encapsulation goes by, I would say, hand in hand. abstraction basically means hiding of a few irrelevant details. So I did not, let me give you a real world example as such. For abstraction, a good example would be a car. If you look at a car, what is the basic functionality which you do in a car? You have a steering, you have brakes, you have accelerator, you have windows and things like that, right? When you want to accelerate, you just press the pedal and it accelerates. Is that all what is getting done under the hood? No. Under the hood, when you press the accelerator, the engine gets a booster and like more oil and more things flow into that engine. And like, I'm not a mechanic, so I don't understand the whole, or electrical or a mechanical engineer, so I don't understand the whole thing of it. But this is how it works, right? There's a lot of things which goes into while you're trying to accelerate. But what we have done, we have abstracted those whole things out, and you just press the accelerator to just move faster. So that's what an abstraction is. So even in a class, right, there would be a lot of properties which would be important for you to define the state of that class. But that might not be useful for the outside world or people who are using it. It might not be useful for them, or they would not be probably interacting with them directly. So the things which you do is you abstract it out. So you can have private methods in a class. And most of the time, this private methods act as a bit of an abstraction where you're not defining everything as public. You're defining a few things as private or any other access, like restricting the access, and you're abstracting out what needs to be known for the outside world to do it. Coming back to the car example, a car would have an engine, would have like lots of nuts and bolts and carburetor and things like that, right? When somebody presses accelerator, does he or she needs to know about everything which is happening in the engine? No, they just need to know that, okay, if I do this, I can move faster. The same thing which you can do while implementing in a class itself. I could define like if I had to make a real a car as a class, and I want to define a method, I would just define a method as accelerate. What does accelerate do? That's abstracted out from the outside world. So when somebody says that, okay, accelerate, the car would just move faster. They would not get to know about all the abstractions or all the details which are happening inside this, right? So abstraction is similar to that you only expose a few functionalities which is needed for the person or the object who's calling it to do a specific operation. Not everything is exposed out. So now we have moved from encapsulation, abstract, and inheritance. Inheritance basically means that you have some structure. What you're trying to do in a child class, what you're trying to do is basically inherit those properties or those behaviors. A child class can innate. So basically, a child class in this example. Let's go by example, right? For sake of simplicity, I'll just remove this time being, and I'll just remove this. If I just remove this, it's fine because it says okay. Now if I just look into this, right? What's happening? Done. Yeah. So this is a child class, right? I have inherited this is a child class, and I have inherited all the properties of the parent class. So I'm basically reusing properties and things from the parent class. Now I can choose to change it or modify the behavior, right? So I can modify the behavior of how done works. Instead of using the default or the behavior which is defined in the parent class, I can modify it. But it helps me with reusability and things like that, right? So that's what's an inheritance is. So in terms, acquires all the properties and behaviors of the parent object. Okay. It's kind of a relationship, which basically means that a certain type, a driver is a type of person. A cook is a type of person. It's used for method overriding, which is also called as runtime polymorphism, and code reusability. I talked about this, right? So instead of defining the same behavior in all the classes, you can just inherit from the parent class and have the behavior in the parent class as such. Okay. Okay. Some terminologies. Class we talked about. Child class is basically the class which is extending out of a parent class. Parent class is a superclass, and we use a superclass, super keyword to call the constructor of the base class. Reusability, you can reuse the states and behavior. Okay. I'm not going to go into examples because I think we've done a live demo of these examples. Okay, type of inheritance, just for you to know, class A, class B, which is basically a class B extending out of class A. You can have multi-level, where there's a class B which extends out of class A, and a class C which extends out of class B. There's something called as hierarchical, which we have done an example of. So in our example, person is class A, driver is class B, and cook is class C. It's a hierarchical inheritance example. Then there's something else which is called as multiple inheritance, which is class C derived from class A and class B. Java does not support it, and we saw an example where if you try to extend from a class, like you can only extend from one class as such, so you will not be able to do multiple inheritance. There's a way in which you can get those kinds of behavior by implementing from multiple interfaces. So you are not allowed to implement. You're not allowed to extend from multiple classes, but you're allowed to implement multiple interfaces, because interfaces don't have like behavior defined. Those just contacts, so you would be able to do that. I think a lot of languages, I don't know whether if I remember correctly, probably C++ allows it to be done. Somebody who's an expert on C++ or has worked with C++ can help us out here.
Yes, multiple inheritances there.
Yeah, and it creates a lot of complexity, I would be honest.
Yes, really.
Yeah, because you would have a difficult time wrapping your head around it. So I feel in some ways Java has done a good job by not allowing it. If you want to achieve that kind of behavior, you can do it using some interfaces. But yeah, I think I'm happy with not having multiple like inheritance in Java, because
yeah, Ajit, one point on this. In modern C++, that is C++ 20, now really lots of good things are there, and that is almost 90% same as Java. So now they are avoiding all these things, and slowly they are retiring all the old things which are creating troubles and all.
Yeah. So I think people have realized that it probably that adds a lot of complexity, and I think even if I remember correctly, people, even though the language used to give you the functionality of doing this, most of the time people would say just avoid doing this, because it becomes a bit messy when you're trying to maintain a code like that, right? So it becomes difficult to comprehend that what's happening, from where it is coming, and things like that, right? There are a lot of nuances around this. So.
Yeah.
Okay. And hybrid is example of hierarchical plus multiple. I mean, hybrid is basically using any of the previous inheritance. If you use two of these or two or more of these, you will get a hybrid structure. Okay, so polymorphism basically means taking different forms. So an example would be in a chess, right? In chess, you can make a move, right? And the move can be different depending on the type of piece which you have, right? A knight would have a different move, a bishop would have a different move, and all of those, right? So it basically means taking multiple forms. And in a few examples which we have already done before, we have already seen polymorphism. So if I go back to the example in-person demo, right? We can see this, right? When we say person interface driver is equal to new driver, right? I could assign at runtime, I could assign a different class to it, right? So basically, the person interface is not just like statically bound to a particular object of a class, right? It can take any object which is basically implements that particular interface as such. So at runtime, the behavior can change. And somebody asked me about this, right? Like, when does the assignment happen? Is it like a compile time thing, or is it a runtime thing? So polymorphism is basically mostly runtime. And this is two ways to do polymorphism would be this. One example is this, where you use an reference of a parent class or an interface to assign like an object of an object which is implemented or extended from those interfaces or classes, and the other would be like by overriding the method behavior in a child class. So I could basically choose. So when I override a behavior, it basically at the runtime it chooses which method to call. Do I need to call the parent method or do I need to call the child's method as such? If the behavior is defined in a child method, it's mostly going to call it. Right? So that's polymorphism as such. We're going to see this is going to become much more clearer in when we start like working on the different design patterns as such. But overall, this is what it is. Okay. Now this is an interesting piece, and I'm not going to talk about all of these at this point of time, but think about this is these are the design principles. These are not design patterns, I would say. These are the design principles as such. So I'm just going to talk about this. I'm not going to take examples because if I discuss about all of these, probably that's the whole course as such. So we would so whenever we're discussing a creational design pattern or some X design pattern, I'll talk you about what principle does it follow and what it does not follow well and things like that. And there's always going to be trade-offs as such. No pattern would do everything right and things like that. And there's always going to be trade-offs. Now, after studying all of these, if you look at any code and says that it just violates some of these design principles, it's going to be true. I don't think so. You will find a code which will follow all the principles. When you do something in X way, you're going to have to take a trade-off. When you do something in a Y way, you'll have to take a trade-off, and it's always going to be there. But the general guidelines is when you're trying to accomplish a specific task, look into how using one or few of these design principles would help you achieve what you need to do. Right? So that's going to be the case. So I'm not going to talk about a lot of these. I'm probably not going to touch upon all of these, but I just put this in the presentation because I would want you guys to know about this. And whenever we're discussing any of the design patterns, feel free to prompt out that, okay, this follows single responsibility principle or this breaks single responsibility principle. This is not open closed. And I remember in the first class, somebody was talking about solid. More or less, this includes everything in solid. How and why? I've seen people basically like remembering stuff about solid that like single responsibility principle. But what does single responsibility means? Open for extension, close for modification. What does it actually mean? So we're going to discuss this, and when we're doing all the examples in the design patterns, probably then it becomes more clearer because I'm going to prompt you and say that, okay, this is the place we're doing this, and this is the place we're not doing this well. So you'll have you'll have more clarity and such. One more thing about design patterns and things like that. Design patterns are not codes or not an implementation, I would say. It's a way of thinking. So given up, like you first need to comprehend about these design patterns as such. Sometimes it will not come very easily. For me also, it's been hard. It's not been easy at the first example, which is, see, you will be able to understand like what does this principle mean, this pattern means as such. You'll have to look into this. You have to understand. And then after like you're able to comprehend, you would be able to pick up those design patterns and use in specific cases and say that, okay, this fits a creational design pattern well, or this fits a strategy design pattern well, and things like that. So it is going to take time. It's going to take practice. So don't worry about it. Probably even in the few classes, we're not going to be able to understand all of this. You are able to look at the example and see like, yeah, this seems to be good. But once you're getting a problem, you might not be able to see that through, or you might have problems. Actually, how do I do this? How do I use a creational design pattern here or an abstract factory pattern here, right? Those might be the cases, but don't worry about it. It will take some time, but you will slowly, once you practice more, you will be able to understand.